All right, so let's analyze this combination circuit here. It's a little bit of series, a little bit of parallel, but all Ohm's law. So we got a table set up, 6 ohm, 4 ohm, 2 ohm. Here we go, 40 volt source. So I'm going to take care of the parallel parts first and look at, see if I can get the current through each of these branches here. So, current equals voltage over resistance, 40 volts across the 2 ohm resistor. That's a terrible omega symbol, but we'll go with it. So there should be 20 amps going through this one. I'm going to try to stay color coordinated to the best of my ability and make that a little smaller. 20 amps. Let's fill it in on my table. We got 20 amps going through C, fairly high, but it's okay. And now we have the second branch. And the second branch is actually two resistors in series, the 6 ohm and the 4 ohm. So any charges coming through there are really going to face both resistances. And resistance in series just adds up. So current equals voltage over resistance. And this would be the current for A and B. I should have labeled this current for C. Add little subscripts there. The voltage across the whole thing is still 40 volts, but I need the total resistance for that, which is really 6 plus 4, or 40 over 10, which would give me 4 amps for the current in branch AB. Now it's going to be the same for both because they're in series. And as soon as 4 amps starts coming through here, there's nowhere else for it to go. It has to go through here as well. So there's 4 amps. Great. Now if I wanted the total current going into the battery, into the source, and from the source, I'm just going to add all of these up. 20 plus 4 would give me 28. Oh, wait a minute. I label this twice in my table because there's two of them, but it's really only 2 branches, not 3 branches, so be careful. This is really only 24 amps, not 28. Great. Now, what's the voltage across these? Well, for C, this is the only thing in that branch, so every branch in this parallel thing is going to have 40 volts across it because it is in parallel. 40 volts here is connected right to that side, and again, nothing blocking it, no energy getting used up right to that side. So 40 volts right across C, and now I have 40 volts across both of these resistors, and that's going to get split up in series. Now in series, current stays the same, voltage adds up, so it's got to add up to 40, and I'm going to use Ohm's law here to figure that out. V equals IR. So I of 4 amps times 6 ohms would give me 6 times 4, 24 volts. 24 volts for that 6 ohm, and 4 times 4 would give me 16 volts for that one. And just to make sure, that should add up to 40. 24 plus 16 does indeed add up to 40. Great. So last but not least, I'm going to find the total resistance, the equivalent resistance for the whole circuit. So looking at, if you were to try to replace this whole thing with one resistor, what would that be? And I'm going to use basically the source info to do that, because the resistance, if I rearrange Ohm's law, is equal to voltage divided by current. I know the voltage is 40 volts. I know the current going through is 24 amps, and that's equal to, not as pretty of a number, but it's hard to design circuits with pretty numbers, 1.6 repeating. Oh, it's not so bad. 1.6 repeating ohms, which is pretty small compared to the other resistors in here. But for anything in series, the equivalent resistance is always going to be less than the smallest resistor in there. Because again, if it was just the 2 ohm, it'd be 2 ohms. As soon as you add another branch, you're opening another door, which makes current easier to flow through, so it decreases the total resistance. There we go.